numerical differentiation. 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 Numerical differentiation. Concepts. 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 Numerical differentiation is the process of computing numerical differentiation numerical differentiation is the process of is the process of computing or finding so computing computing process of computing or finding or finding or finding the derivative of a function at the given point of derivative of a derivative of derivative of a given point pt means point given point using set of given tabulated values using set of given tabulated values given set of tabulated values tabulated values tabulated values of the function the function of the function of the function. The problem of numerical differentiation is solved by representing the function with an interpolation polynomial or interpolation formula and differentiating this polynomial as many terms as required to obtain the desired order of the derivative. Etc. To obtain the desired order of derivatives. Order of derivatives. Derived order of derivative. Desired order of derivative. So next. Numerical differentiation is the most important uh, 10 marks question. Page number 211. Example 1. Page number 211. Page number 211. Example 1. Example 1. Find dy by dx. Find dy by dx and d square y by dx square. D square y by dx square at x equal to 1.2. At x equal to 1.2. Using the following data. Using the following data. Using the following data. Following data. So table is given x. What are the values? 1.2, 1.4, 1.6, 1.8, 2.0, 2.2. So y equal to f of x. Y equal to f of x. 3.3201. 3.3201. 4.0552. 4.0552. 1.6. 4.9. 4.9. 530. Next. 6.0496. 7.3891. 3891. 9.0250. 50. So solution. 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 So here h equal to 0.2. How to find h? 1.4 minus 1.2 or 1.6 minus 1.4 or 1.8 minus 1.6, etc. Class interval difference, nothing but h. Next, we have to find dy by dx and d square y by dx square at x equal to 1.2. Here x equal to 1.2. X equal to 1.2. 1.2 is the beginning of tabular data. Is beginning of the tabular data. Beginning of the tabular data means x naught is also 1.2. X naught is also 1.2. Then you need to find out. So hence use the Newton forward difference interpolation formula. Obtaining the derivatives. Then we have x naught equal to 1.2. Then x equal to 1.2. U equal to that equal to u equal to x naught x minus x naught by h. X minus x naught by h. That equal to x naught is 1.2 minus 1.2 whole divided by difference is also h is also 0.2. That means that equal to 0. Means what we have u equal to 0 we got. Okay, 0 we got. Next. Next, construct the table. Construction of table. Construction of table. Construction of table. Of table. Construction of table. Construction of table is x x y equal to f of x, y equal to f of x, del y, delta square y, delta square y, delta cube y, delta cube y, delta 4y, delta 5y, delta 5y, delta 5y. So x values, we know that what is given 1.2, 1.4, 1.6, 1.8, 2.0, 2.2. Y equal to f of x. F of x values 3.30, 3.3201, next 4.0552, 4.0552, next 4.9530, 4.9530, 9.30, 6.0496, 0496, next 7.3891, 7.3891, 1.6359, 1.6351. So delta 0.7351, 0.7351. Next 0.8978, 0.8978, 0.096, 0.9966, 1.33, delta y, delta y. So delta y is difference 4.055 minus 3.3201, subtraction. Subtract from down value to up value. Y equal to f of x is there now. 4.0552 minus 3.3201. Similarly, 4.9530 minus 4.050552, this value. Similarly, down minus up, like that. Next delta y, 1.3395, 1.3395, 3395. Next 1.6359, 1.6359. This is nothing but 1.6391. 1.3891. 9 point. You are welcome. Next, delta square. Delta square y naught is also like that only. 0.8978 minus 0.7351. That is delta square is 0.1627. 0.1627. Next, 0.1988. 0.1988. Next, 0.2429. 0.2429. Next, 0.2964. 0.2964. Next, delta cube y. Delta cube y. So we are using forward now. That's why these values we need to use in formula. Substituting. That is 0.0361. 0.0361. 0.03. 0.0441. 0.0441. 0.05. 0.0535. Next, delta 4. 0.0080. 0.0080. 0080. Zero point double zero eight zero. 0.0094. 0.0094. Next, 0.001. Delta 5. 0.014. We will use. So next. So Newton's forward difference formula. Newton's forward difference formula. Newton's forward difference difference formula for derivatives. dy by dx at x equal to 1.2. dy by dx at x equal to 1.2. 1.2. dy by dx. dy by dx. U equal to 0. That equal to 1 by h. 1 by h. delta y naught, delta y naught minus 1 by 2, delta square y naught, delta square y naught plus 1 by 3 delta cube y naught is 1 by 3 delta cube y naught, delta cube y naught minus 1 by 4 delta 4 y naught minus 1 by 4 delta 4 y naught plus 1 by 5 delta 5 y naught will here is that. Substituting these values means from substituting the corresponding values from the table by putting the corresponding values from table dy by dx at x equal to 1.2 that equal to 1 by h. H means out 0.2 class interval difference, nothing. That equal to delta y naught. Delta y naught is 0.7357351 from table minus 1 by 2. Delta square y naught. Delta square y naught is 0.1627. 0.1627 plus 1 by 3 delta cube y naught. Delta cube y naught is 0.0361. 0.0361 minus 1 by 4 delta 4 y naught. Delta 4 y naught is 0.0080 plus 1 by 5 delta 5 y naught is 0.0014. So on simplification, we obtain 3.3200 approx. This is not exact value, approximately. Right. Next, we need to find out d square y by dx square. Another one, d square y by formula. SIP, Newton's forward difference interpolation for derivatives of second order. Second order is d square y by dx square x equal to 1.2 that equal to d square y by dx square at u equal to 0 that equal to 1 by h square delta square y naught delta square y naught, delta square y naught minus delta cube y naught, delta cube y naught, delta cube y naught plus 11 divided by 12, 11 by 12, delta 4 y naught, delta 4 y naught, delta 4 y naught, delta 4 y naught minus 5 by 6, delta power 5 y naught, 5 y naught plus so on. Substituting the corresponding values from table, we obtain d square y by dx square at x equal to 1.2, that equal to 1 by h square means 1 by 2 whole square, 1 by 0, 1 by 0.2 whole square. So delta square y naught, delta square y naught is 0.1627, 0.1627 minus delta cube y naught, delta cube y naught 0.0361, 0.0361 plus 11 by 12, delta to the power of 4, that means 0.0080, 0080 minus 5 by 6, minus 5 by 6, minus 5 by 6, minus 5 by 6, 0.014, 0014. On simplification, we obtain 3.055 approximately. Okay. Today we discussed it. This is 10 marks question. Proof, disproof, formula proof, and problem is 20 marks. Section C. Possibility is there. Next. Next. So Newton's backward interpolation formula. So another example. First we did forward, now backwards. Page number 216. All of his students follow. Example. Example 2. Find dy by dx at x equal to 0.06. Find dy by dx. Find dy by dx at x equal to 0.06, at x equal to 0.06 from the data, from the following data, from the following data. data from the following data table. Table X 0.1, 0.6, X equal to 0.01, 0.01, 0.02, 0.03, 0.04, 0.04, 0.05, 0.06. So then y equal to f of x, y equal to f of x, y equal to f of x. 0.102, 102, 0.105, 0.105, 0.110, 0.110, 0.112, 0.112, 0.111, 0.115. So solution. Here h equal to 0.01 because 0.02 minus 0.01 is class interval difference, nothing but. Then we have to find divided by days at equal to 0.06. So here x equal to 0.06, 0.06. Hence the point x, end of the tabular data. So choose the origin x naught. Have to choose the origin x naught 0.06. Have to choose the origin. Choose the origin at x naught. At xn equal to 0.06. So u equal to x minus x naught or xn all divided by h. That equal to 0.06 minus 0.06 whole divided by 0.01. We get 0 by anything is 0. That implies u equal to 0. U equal to 0. Right. Next. The Newton backward difference formula. Afterwards, first construct the table. Construction of table. Construction of table. Construction of table. Construction of table. First x 0.01, 0.01, 0.02, 0.03, 0.03, 0.04, 0.05, 0.6. Y equal to f of x. Y equal to f of x. Y equal to f of x. 0.102, 0.102, 0.105, 0.107, 107, 0.110, 0.110, 0.112, 0.115, 0.115. So del y, del y, del y, 0.003, 0.002, 0.002 is 0.003, 0.003, 003. Next, 0.002, 0.002, 0.003, 003. This is del y, del y. Next, delta square y, delta square y, delta square y, minus 0.001, minus 0.001, 001, 0.001, 0.001, 0.001, 0 minus 0 point, minus 0.001, double 0.01. Next, 0.001, 0.001. Next, delta cube y, del cube y, del cube y, del cube y, 0.02, 0.002. Next, minus 0.002. Next, 0.002, 0.002. 0.04. Next, delta to the power of 4y. Delta to the power of 4y. Delta to the power of 4y. Minus 0.004. 0.004. Next, delta del power 5 y. Del power 5 y is 0.008. Let's backward. Now we'll write formula, Newton's backward difference formula for derivatives given by Newton's backward difference formula. Newton's backward difference table. Backward. Newton's backward difference formula. Difference formula. Difference formula for derivatives. For derivatives. For derivatives. For derivatives. dy by dx. Dy by dx at x equal to 0.6. 0.06. 0.06. That equal to dy by dx. Dy by dx. U equal to 0. That equal to 1 by h. 1 by h. Del by n. By n. Plus 1 by 2. 1 by 2. Delta square y n. Delta square y n. Plus 1 by 3. 1 by 3. Delta cube y n. Delta cube y n. 1 by 4. 1 by 4. Delta 4 y n. Delta 4 y n. Plus 1 by 5. Delta 5 y n. Delta 5 y n. So that equal to substituting the corresponding values from table, we obtain 1 by h. H means 0.01. This is not 4, this is h. H. Delta y1. Delta y is 0.003 plus 1/2 delta square yn, that is 0.01 plus 1/3 delta cube yn, that is 0.004 plus 1/4 delta 4yn, 0.004. Next, plus 1/5 delta 4 delta del power 5 yn is 0.008 0.008. So on simplification, we obtain 0.68 approximately. Approximately. So next one. Differentiation based on central difference interpolation formula. Means find the derivatives using Stirling correlation. Stirling interpolation differentiation formula is nothing but average of Newton's forward and Newton's backward. Newton's forward and Newton's backward formula. Newton's forward and Newton's backward. So we'll discuss one problem based on the page number 220. Example 3. Example 3. Find dy by dx at x equal to 1.4. Find dy by dx. Find dy by dx. Find dy by dx at x equal to 1.4. X equal to 1.4. From the following table. And following from the table. From the following x 1.2, 1.3, 1.4, 1.4, 1.5, 1.6. Y equal to f of x. Y equal to f of x. 1.510, 510, 1.698, 698, 1.904, 904, 2.129, 2.129, 2.376, 2.376. Clear question. No solution. Solution. Here h equal to 0. Here h equal to 0.1, 0.1. And we are required to find dy by dx at x equal to 1.4 a point x equal to 1.4 is the middlemost value of the data. The middlemost value of the data. Middlemost value of the data. So x naught equal to here 1.4. X naught is also 1.4. So automatically we'll get u equal to x minus x naught by h. That equal to 1.4 minus 1.4 whole divided by h is 0.1. That equal to 0. That implies u equal to 0. U equal to 0. H value ఎలా find చేయాలి? Okay. H value from table. Come. What's the table? X value is there, no? Here x value is 1.2. Here x 1.3. 1.3 minus 1.2, 0.1. 1.4 minus 1.3, 0.1. 1.5 minus 1.4, 0.1. 1.6 minus 1.5. This is class interval difference. Same. Understood? Any doubt? Class interval difference. Second term minus first term, third term minus second term. Like that. Okay.
Okay.
Now we know that u value and h value and x value also. So construct the table. Construction of table. Construction of table. Construction of table. So x. Next. U equal to x minus 1.4 divided by 0.1. Then y. Next. Delta y. Next. Delta square y. Delta square y. Delta square y. Next, delta cube y. Delta cube y. Next, delta 4y. Delta 4y. Delta 4y. So x equal to 1.2, 1.3, 1.4, 1.5, 1.5, 1.6, 1.6. Next, here -2, -1, 0, 1, y values 1.510, 1.510. Next, 1.698, 510 or 501, 510. 1.698, 698, 1.698, 1.904, 1.904, 904, 2.129, 0.129, 2.129, 2.376, 2.376. Delta y 0.188, 0.188. Next 0.206, 0.206, 206, 225, 0.225, 0.225, 0.247, 0.247. Delta square y 0.018, 0.019, 0.022, 0.022, 0.001, 0.001, 0.003. Next 0.002. So from tables, so Stirling interpolation, Stirling formula for derivatives, Stirling formula, Stirling formula, Stirling formula.